25, we're going to classify the numbers. Let me make a little chart here. We've got 4 numbers. There's 1, 2, 3, and I'm going to sneak one more in here. We're supposed to decide if they are real, rational, irrational, integer, or a whole. And then put them in order from least to greatest. So I'm going to start here. I'm going to say real. I'm going to say rational, irrational. Is it an integer? Is it a whole? We've got negative root 12, negative 3.7, square root of 9, which we know is 3, and 2.9. Well, every number is a real number that you guys have ever dealt with, so they're all real numbers. Rationals can be written as fractions. Doesn't include square roots of imperfect squares, but terminating decimals are rational. Square root of 9, which is a nice integer, those are rational. 2.9 is a terminating decimal, so it's rational. Square root of 12, again, that was an imperfect square. When you take the square roots of those, you get irrational numbers. As far as the integers go, this decimal would go on forever. This is a decimal, but 3, that's an integer. It's also a whole number. I think our table is complete. Putting them in order from least to greatest. Negative root 12, you could approximate that. You think 12 is kind of stuck between 16, negative 16, and maybe negative 9. Negative square root of 9, well, that's going to be negative 3. Negative square root of 16, that's negative 4. Negative 12, negative root 12 is a little closer to negative root 9, so maybe negative 3.3, something like that. Kind of helps us if we put them in order from least to greatest. Our biggest negative would be negative 3.7. Then we'd have that negative 3.3-ish, which was negative root 12. Our smallest positive was 2.9. And then we had 3, which they wrote as the square root of 9.